Hello champions, welcome to day 2 of our 99% in 99 days series. We have created this series to help you achieve 99% marks in your board examination. Alright, so if you are confident, if you are following this consistently, I am confident that you can actually achieve this, the goal of 99% in your board examination. Alright, so today's session will talk about real numbers, particularly we'll talk about LCM and HCF. Okay, so we'll see what are the definitions of LCM and HCF, we'll see and solve questions on HCF and LCM. Okay, for the first chapter of our CBSE grade 10, let's solve them. Let's start the chapter from the first basic concept that we have, bacha. Okay, so before moving to the concept part, let's see the chapter plan. What is there in the chapter, sir? So if you remember, if you recall, the first thing is what? The fundamental theorem of arithmetic and prime factorization. Sir, is this a unit? It's not a unit, bacha. It's like a prerequisite. You have to know this thing to move ahead and help solve the questions in HCF and LCM. Prime factorization is very, very important, okay, because it will solve numerous questions with the help of prime factorization in HCF and LCM. Again, in the second part, you also have word problems, okay. Then sometimes they ask questions on directly this theorem, fundamental theorem of arithmetic. You can expect this question for 1 mark. Sometimes they also ask you for 2 marks also, but you can expect one question from here also. All right. Now irrational numbers is there. This I don't, I can't believe it. They have asked 5 mark question from irrational number. Okay, they simply say root 5, prove it root 5 to be irrational, root 2 to be irrational, and you get the how much marks? 5 marks over there, which is very, very, very simple problem. So this is your chapter plan. Moving on to with the weightage of the chapter. So if you see here, the total from the real numbers, total 6 marks can come, right? Out of 6 marks, if you see, what type of questions can be expected from the real numbers? From HCF LCM, you can expect 2 marker MCQ and 3 marker 4 marker, right? Because 4 mark also, if there's a word problem, okay, which is if there's a word problem, they can ask for 3 mark, which is a simple word problem. Let's say simple HCF LCM based question, they can ask 3 marker. They've also asked, what is 4 marker? Case studies. Okay, they'll give you a situation, they'll give you criteria, conditions, and based upon that, they'll ask you to solve a case study in HCF LCM. MCQ can be also asked at the same time. Again, from the irrational numbers, MCQ 5 marker questions. Okay, as I said, proving the number to be irrational, and then number 3 marker questions can be expected. This is again expected questions. Weightage is 6 marks. You can expect the questions from this topic HCF LCM and rational number like this 2, 3, 4 marks and MCQ and 5 and 3 marks. All right. Moving to the first topic, which is what is it, bacha? Fundamental theorem of arithmetic. Fundamental theorem of arithmetic. What is it? It states that very simply, very simply, okay, that any composite number that we know of, any number, sir, we can think of a lot of numbers, sir. We can think of 18, sir. We can think of 6, sir. We can think of 16, sir. Okay, we can think of more numbers as well, sir. 42, sir. Okay, so we can think of a lot of composite numbers. The theorem of arithmetic states that any composite number can be expressed in the form of its prime numbers. Means I can express this 18 as, please check, this 18 as 2 times of 9. Again, I can write this as 2 times of 3 times of 3. So if you see here, 2 is a prime number, 3 is a prime number. Okay, so I can express this number 18 as 2 and 3 in the product of 2 and 3. So if you read this statement, according to the fundamental theorem of arithmetic, every composite number can be written or factorized as the product of prime numbers, and its factorization is unique, okay, apart from the order in which the prime factors occur. Correct? Alright, so this is true. Why they are saying factors? Because think about it, no, 2 and 9s are what? Factors of 18 only, no? Same way, 3 and 3 is what? Factor of 9, right? So either write it as product or factors, remains the same thing. Think about 42. I can write this 42 as 6 times of 7. I can write this again as 2 times of 3 times of 7, which makes 3 prime numbers, 2, 3 and 7 coming together in the factor form or the product form to give me the number, the composite number 42. Alright, let's see the first question on this. Okay, this question, 14 times of 41 times of 5 plus 14 is a composite number. We have to prove that and we have to see why it is. Okay, when can we say the number is composite? Whenever I can express in the form of primes, product of primes from the fundamental theorem of arithmetic. Please have a look. Very simple question. 14 times of 41 times of 5 plus 14. Okay, can you see 14 is common? Take 14 common, please. How much you're going to get if you take common 14? You'll have 41 times of 5 plus 1. Excellent, excellent. What is this going to be? 2 times of 7. How much is this? 5 ones are 5, 5 fours are 20. So 2 not 5. Okay, plus 1. How much is this? 2 times of 7, and how much is this, bacha? 206, 206, okay. If I have to expand this, I can write it as 2 times of 7. Can I write 2 again over here? So I'll get it as 2 times of 103, 103, okay. And is 103 a prime number? 3 plus 4 not divisible. Let's check with 7. 7, if we do that, we don't get 7 ones are 7. We have 3, 33, no. So we take 9, not possible. Then we can take 13, not possible, okay. 13 also not possible. 13 no possible, yeah. Okay, then what we can take? 19. 19 sevens are, how much is that? Please check. No, not possible, right? Okay, so that is also not possible. So yes, it's a prime number. So if you check here, I get this number as 2 times of 7 times of 2 times of 103. Means the given number can be written in the form of what? Product of prime numbers. Product of prime numbers. Hence, it is a composite number. Hence, it is a composite number. Very, very simple. Okay, I hope you understand this. Moving on, what we have next thing, prime factorization, tool to solve any question or most of the questions in the case of HCF and LCM. So I hope you have this some idea about this. If not, it's okay. So prime factor means what? I take any number, I can write this number. Let's say I can take the number 84. 84. Prime factors means what? Write this number 84 in only prime factors. Okay, means write the factors in this in only terms of prime numbers. So I can write 84 in multiple ways, right? I can write it as 42 into 2. How much is that? 2 to the 4, 84. But is this a prime factor? No, sir. I want only prime numbers. So what can I do, sir? I can write it as 84 divided by what? Please check. I'll take 2. First prime number is 2. 1 is neither composite nor prime. So if I take 2, 42. Over here again 2, so 21. Again 3, so 7. What I end up with, please have a look. I can write this number 84 as what was 2 times of 3 times of 7. How much I'm going to get for this? 2 squared 3 times of 7. So this is my prime factorization for the number 84. Okay, this is how we use this. We write the number given in the form of product of only prime numbers. Okay, if I have to take few more examples, let's see. Just to make work interesting, I can take what? 196. Can I take 196 also? Simple number, very simple number. Okay, take with again what? So if it is divisible by 2, no, take with 2. Why 2? Because we will have to have 2, no. Prime numbers has to be there. So if it is divisible by 2, so last digit is 6. I can divide by 2. So take with 2, bacha. 2 9s are 18. 1 is a carry, so 16. Again 8. I can take 2 again, sir. 49. Yes. So please take 49. Okay. What is next? I can take 2. No, sir. Can I take 3? No, sir. Can I take 7? Yes, sir. What is my number then? I can write this 196 as what, sir? 2 squared times 7 squared. 2 squared times 7 squared. Alright, this is for your prime factors of 196. Alright, moving on. Okay, this is for your DSAT. So if you are wondering what is there, sir, after grade 10, okay. So as Diksha does every year, we are organizing at Diksha DSAT program. In this, what is DSAT program? It is a combination of aptitude and scholarship test. So what you have to do is take up this test. Okay, how can you do that? Go to the link given in the description, enroll now. Okay, how can it benefit you? If you enroll now, you'll get all the details, how to take the test, all the information about DSAT you'll get after enrolling, and you can just visit the link in the description box and you can enroll directly from there. Now, benefit of this, what is the benefit of DSAT? So what it does, no, it helps you make the right career decision between what? Science and commerce. It can help you choose, okay, there, and also help you assess your competency for JEE, NEET or KSET examination. So please make use of this opportunity that you have and make the best decision for your career. Alright, let's move on. Let's move on to the HCF and LCM of real numbers. Okay, HCF and LCM of real numbers. Achha, one more thing. So I think you have solved a lot of questions, no, on HCF and LCM. Okay, this is just we are trying to recall this thing. So I'll try to give you two definitions for HCF and LCM. Okay, one is what is written over here, and another one how to solve a complex question whenever it is given in the form of lot of prime factors are given there, even it is a variable. So second method that I'm going to give you can be applied to variables also or a real number also. If I have I have to find HCF for variables, okay, that will also be applied there, and for numbers also you can apply the same approach. I'll give that to you. So we'll see that. For now, HCF, what is HCF? The largest integer that two or more numbers can be divided by. Correct, right? If I take two numbers, let's say I took the numbers, right, 84 and 196, 84 and 196, the largest number I can divide both of them by. Okay, means I should take a number x such that it divides both these numbers, it divides both these numbers. That number will be called then what? HCF. What is HCF? Highest common factor, or we also call it as sometimes GCD. We also call this as GCD, greatest common divisor. Greatest common divisor, excuse me. But usually we call this to be most commonly highest common factor, bacha. I hope this is clear. Highest common factor. Alright. What's the definition? The biggest number which can divide both of them. Please have a look. Please have a look. We've got it over here, right? What's the biggest number that can divide both of them? Please check. 2 square is there. 2 square is there. Okay. We also have 7. We also have 7. Okay. So means what? 4 times of 7 ones. How much is that? 28. How much is that? 28. 2 square is 4. One of the 7 I can take because only one 7 is there. So 2 square and 7. Okay. You'll see. I'm going to give you the second approach. You'll understand that. So 28. 28. How will this work, sir? Please have a look. So if you say 28, 28 times what? Take this 3. How much is this? 24. 28 times 3 is 84. What about this? 28 times what is 196? Please check. So I think 8. Is it 8 times? Please have a look. No. 28 times what is this? So if you check 7, I think 7. Okay. Not 6. It is 7, bacha. It is 7. Okay. Correct, no? 8 7s are 56, so in hand 6, 7 2s are 14 plus 1, 14 plus 5 is 19, so 196. So 28 is the largest divisor or greatest common divisor for both the numbers. So I can write HCF as what? My HCF as simply 28, sir, for the given two numbers. So X value is what? 28. Simple enough. Okay. Now I said I'll give you one more rule for this. I'll give you one more rule for this for HCF. Okay. This will be very, very, very helpful. Please make a note of this. Okay. So what is this rule, sir? So look for take what you're gonna do? Take common factors. Take common factors with what? With least power. With least power. Please understand this. Least power. I'll show you from the previous example. Common factor with the least power. This is very, very important for HCF. Remember, take common factors, okay? All the common factors you have to take and with the least power. So I showed you over here. For 84, what we wrote, if you remember, for 84 we wrote it as, how much was this? 2 square, so 4. Then there was a 3, I think, then 7. Okay, please check. 2 square, 3 and 7. And what was this? 2 square, 7 square. 2 square, 7 square. So for what is it, bacha? For 196, I have it as 2 square, 7 square. What is the rule I gave you right now? Please have a look. I said that take common factors. What's the common factor? 2 and 7. 2 and 7. So take this. I write this HCF as 2 and 7 with the least power. With the least power. What is the least power of 2? Sir, both places only 2 in 2 is there. Over here also 2, over here also 2. So write here 2 square. For 7, sir, I have over here as 1, over here as 2. I am asking you to take only least power. So you'll take it as 1. What is my answer? 2 square times 7. How much is that? 4 times 7. How much is that? 28. How much is that? 28. Same result I've got here as 28. So to find HCF, use this concept. The definition of HCF is the largest number that divides both the numbers or 3 numbers, whatever is the number given, 2 number, 3 number, whatever it is. So the largest number that divides all of them is GCD or HCF, or also the simplest way to understand is take all the common factors after writing prime factorization. Write the prime factorization, take all the numbers and take all the common factors with least power. With least power. I hope this is very simple. I hope I have simplified this and this will help you understand. Okay. So let me take few more examples and we'll see how can we apply this. I'll take 3 numbers now. So let's take 36, okay, I can take here as 44 and 92. 36, 44 and 92. Okay, what is the first step, sir? Step 1 is, understand this, very important, very, very important. Step 1 is what? Do the prime factorization. What is it? Prime factorization. So let's do it. I'll do for 36 first. So 36 I can write it as 2 times of 18, right? So I can write it as 2 times of 18, 2 times of 3 times of again 6. So if you want I can do it roughly over here. 36 as 2 times of 18, 2 times of 9, then 2 times of, so 3 times of 3. So what I get? I get this as 2 square, 3 square. 2 square, 3 square, bacha, not this thing, 3 square. Have a look. 36 is done, okay. Now same I can do for what? For 44 also. How much is this? 2, 22, 2, 11. So write this 44 as, what? 2 square times 11 times 11. What about 92? Please have a look at 92. 2 times of 4, okay, and 6. Correct, right? 46 times 2 is what? 92. 2 times 4 is 8. 1 is the carry with 12. It will come at 6 times. Again I can take with 2. How much is that? 23. Please have a look. 2 2s are 4, 2 3s are 6. What I get? 92 as. 92 is nothing but 2 square times 23. Okay. Alright. Let me erase this now. Okay. Okay. Now moving on. Have a look. First step is done. Step 2 was what, bacha? Step 2 was look for common factors. What is it? For common factors. What are the common factors? Please check here. 2 is there, 2 is there, 2 is there. So one of the common factor is 2. 3 is there, there is no 3, there is no 3. So 3 I can't write. Anything else? So nothing is there. So I can't even take. And what is the least power? Next is what? Step 3. Step 3 is least power. What is it? Least power. Least power. Okay, least power. So what is the least power, bacha? Please check. Least power is 2 square, 2 square, 2 square. So I have 2 square. So what is my HCF now? This concludes my HCF is simply 4. Simply 4. Now another case. If there is nothing common, let's say I have a case. Okay, very important. Know this. If there is no common factor, there is no common factor given, then what is the HCF? Tell me. HCF is simply 1. HCF is simply 1. If there is no common factor, let's say I have a case where I don't have any common factor. For example, 7 and 9. What's the common factor of 7 and 9? Nothing, sir. 7 is 1 into 7, 9 is 1 into 9, or 3 into 3. But 1 is the common factor for any number which does not have any other common factor. So HCF is 1 for no common factors. Alright. Okay. Now one more thing I wanted to add is what? Alright. So yes, so we have seen how can we apply this concept to identify questions on HCF, to identify questions on SF. Now how to figure it out? The question is just a big question. Okay. This is a very important question. This will help you solve the what problems. So how to identify that we need to find HCF. Okay, HCF. So first clue, look for the number greatest, highest, simplest possible. Simplest clue, look for highest and greatest. Okay, this might not work all the time, but it works most of the time. So look for the word highest or greatest. Okay, highest or greatest, and make sense. Use the statement to make sense for the question. If it makes sense with highest and greatest, HCF it will work. Secondly, if you are looking for a result, so whatever is the result, whatever is the resulting answer, whatever is the basically your answer, okay, if the result is greater than the numbers given, okay, not greater than, sorry, greater than means it will be LCM. So if it is lesser than the numbers given, lesser than and equal to, So basically HCF of two numbers will either be equal to the two numbers, any of them, or less than the two numbers. So HCF will be either less than or equal to, less than or, this is very important, less than or equal to the given numbers, Yes, so think about it. What is the HCF? 4 I got. Is 4 less than 36? Is 4 less than 44? Is 4 less than 92? Yes, sir. Okay. Sir, it can either be less than or equal to. It cannot be more than it. So whatever is the result you are looking for, think about the result. Okay. If the result is coming as, sir, I don't know the result. No, how would I know the result without solving the question? I'm not asking to solve the question to get the result. I'm asking to think about it. Think about the number that they're looking for. Will that number be smaller or bigger than the number they've given? If it is coming to be smaller, if they're giving you, sense that it's going to be a smaller number, then what are you going to get? HCF, you have to find it out, bigger number than LCM, alright. So I hope this is enough. So first thing is how to find this using this approach. Common factors with least power. For no common factor, HCF is 1, and this condition is what, bacha? Then how to identify what to find, when to find HCF, look for these words or try to make sense in the question only. Secondly, always will be less than or equal to the greatest number. So basically the clue is HCF of any number is always less than or equal to the numbers given. Chaliye. Now coming to LCM. What is LCM? As the name suggests, smallest integer which is common multiple of it. For example, the simplest way of is, if you can write the table. So I can't write table for all numbers, but if you can try to write it, table, okay. So in the table of numbers given, look for what? Look for first common multiple, a first common term. For example, let's look for 8 and I can write it as maybe 18. 8 and 18. What about this, bacha? Tell me, 8 and 18 will have what as LCM? So it will be a bigger number actually. Please check. So if I take 8 and 18 only, so the LCM would be what? If I have to write the table, first let me find the LCM. So how you find LCM? Same way, this approach will work now. This method too will work now. First method is what? Write the table, from the table the first common multiple. For example, if I take a smaller number, if I take let's say 4 and 8 first, 4 and 8. Okay, 4 and 8. What is the LCM of 4? Write the table of 4, 4 1s are 4, 4 2s are 8, 12 and go on like this. For 8, I can write 8 1s are 8, 8 2s are 16. Check the first common number. What is that? 8. What is the LCM then? LCM itself is 8. LCM itself is 8. Okay. What about method number 2? Method number 2 is same thing. But over here, step 1 will be what, bacha? Step 1 will be not just common factor, write all the factors, right? What? All the factors, sir. Not just common factor, write all the factors. And second is what? Highest power. If you're taking here least power then, in the previous case, over here we'll take highest power or maximum powers. Maximum doesn't suit. Let's write it as highest powers. So highest power we will consider, bacha. Okay, highest power we'll consider. For example, if I take this 8 and 18 question, what's the 8 prime factorization? 2 cube. What's 18 prime factorization? Please check. How much is this? It's going to be 18, so 2 times of 3 square. Please check. 2 into 9 is what? 18. What's the LCM going to be? Please check. LCM will be what? So 2 and 3 will consider, because these are the all factors. 2 is there for 8 and 3 is also there for 2 and 3 is there for 18. So I'll take all the factors. Highest power, what is it for 2? 3. For 3, how much is that? 2. For 3, highest power is 2. For 2, highest power is 3. 2 cube is how much? 8. What for 3 square? How much is that? 9. What's the answer? 72. So this method will be helpful in that case. But if I have to write the table of this, how will I write? So I'll get someplace 8 9s are what I'm going to get? 72. Okay. Over here I have 80, but 8 9s will be 72. Over here 18 will be what? 36, 54 and 72. Please look at here. First number which is common is 72. So in the table, method number 1, figure out the table if you can figure it out, okay, if it is simpler, and look for the first common multiple. Method number 2 is more suitable in this case. What is that? Write all the factors, highest powers you write for all the factors and multiply them together. Okay. All right. So I hope this is helpful. Please have a look. Yes. Okay. Now this method, the method 2 for both HCF and LCM will work for even in the case of variables. Even if you're dealing with variables, this two case will work. Okay, so I hope you understand that. I hope you understand that, bacha. All right, moving on. What we have next is, okay, HCF and LCM of two distinct numbers A and B. Okay, two distinct number A and B. All right. So for example, I gave you this hint right now. I can take variable also. I'll take a variable and a constant. So let's say I take what? First number as 7 and I can take it as 9. 7 and 9. 7 and 9. What is HCF? I said no common factor. No distinct number means no common factor. Okay. If there is no common factor, what is HCF? 1. What is LCM? Product you take. You take the product. What's the product of this, bacha? Tell me. Product of what? Product of A and B. What is A? 7 in this case. So 7 and 9. What is that answer? 63. 63. Achha, one more property holds here, which is what? Product of the numbers A and B is equals to LCM of the number A and B times HCF of the number A and B. Okay, please have a look. What's the product of the number A and B? If the numbers are 7 and 9, what's the product? The product is what? This side if you check, 7 times 9. What's the LCM? Sir, again 7 times 9. What's the HCF? Please check. What's the HCF? What is it? 7 times 9 again. How much I got? Sorry, HCF is what? 1. Okay, HCF is 1. Alright. How much is that? 7 times 9 also 7 times 9. Isn't that equal? It's equal. So this is the very important property. You're going to use it to solve multiple questions. Product of the numbers is equal to HCF into LCM. So is it only possible if distinct numbers are there? Means if distinct numbers, it's possible only if there is no common factor. No. Some common factor is there also. Even this condition will be verified. For example, I can take an example where the common factors are there. Okay. Let's take example. Okay. I can write it over here. Same concept. HCF and LCM of two numbers. Please check. Two numbers. Okay. Two numbers. I am taking two numbers. Let's say 8 and 12. 8 and 12. What is the 8 factorization? 8 factors are 2 cube. For 12 I have to write what? 2 square into 3. Correct, right? 4 into 3 is 12. What is my HCF? Tell me here. My HCF is simply the common factor with highest, so least power. So 2 cube and 2, 2. So what is the answer? 4. Common factor with least power. What about LCM, bacha? My LCM will be what, bacha? 2 power. All the factors with highest power. So 2 into 3. Power is 3 and power is 1. How much is that? 8 times of 3. How much is that? 24. Please verify the conditions now. What is the property? So product of the numbers, product of what is it? 8 and 12 will be equal to what? HCF times LCM of the same numbers. How much is that? 8 times of 12 is equals to what? HCF is how much? 4 times of 24. Please class verify. This is 96 and this also is 96. So this will not be valid only for the numbers where they don't have any common factor, but everywhere. Okay, but everywhere. I hope this is visible. Have a look. Okay. Now, one more thing before starting the questions, we are moving to the question side now. If you want to download the PDF of the class notes, what you have to do is you have to go to the link in the description, enroll. Okay, fill in the form, and you will get the videos. You will get your videos, your notes, all of this in your mail. So do not forget to do that, because this is a complete process. You must have to follow this to get the notes, to solve all the questions with me. Okay, so do that, fill the form, get your links for videos, get your all the updates, get all of your PDF notes directly to the mail. Don't have to worry about any of that. All right, moving on to the first question. Find the LCM and HCF of 48, 72 and 80. 48, 72 and 80. First approach is what, bacha? Find prime factorization. Let's do it here. 48. I can do with 2. I need prime factor, sir, so I can do with 2. How much is that? 24, sir. 12, sir. 6, sir. Again, we can do once to 2, 3, sir. Please check. 2 to the power 4 and 3. I can write 48 as 2 power 4 times 3. Right? Okay. Next, what is the bacha? 72. 72. So I can do 2 with 2. 36 again. I can do with 2, so 18 again. Not visible. I'll write it again. no problem. 2, so 18 again, and then what I can do with 2 again, so 9, 3 with 3. So how much is that? For 72 I have 2 power 3 and 3 power 2. 3 power 2. Last is what? 80. Last is what? 80. Please have a look. For 80 I'll do like this: 240, 220, 210, 2 and 5. So I get what? Okay. Yes. So yes, 2 power 4, 5. We are looking for what? HCF and LCM. What we know for LCM? LCM will be what? All the power with highest power, all the factors with highest power. So our factors are 2, 3 and 5. So 2, 3 and 5. Write the highest power. For 2 is 4, sir. For 3 is 2, sir. For 5 how much I have? 1, sir. Okay, do one thing. Take this one 2 out here. Write it as 2 cube, 3 square, and write this 5 with the other 2. I have taken 2 from here to here. So 2. Why to make this is just a 10? No problem. How much is that? 8. And how much is this? 9. How much is this? 10. 720. Please check. 720. Okay. 720 is my answer for LCM. What about HCF? For HCF what we do? Only common factors with least power. So common factors are 2 and only 2. Only 2 is there. There is no 3 in this third one. So I have written it as 2 with the least power. So 3. So answer is 8. My HCF is 8 and this thing is, what is it? LCM is 720. I hope this is simple and I hope you understood this. Moving on, question number 2. If the HCF of 65117 is expressible in the form of 65m and 117, do not worry about this right now. Whatever it is, we'll see that later. They're saying that HCF, right? So we'll find HCF. We'll find HCF. Let's find HCF now. So how will I find 65? So 65 I can write it as simple, sir. Factorization of 65 is 13 times of 5. No problem there. What about 117? For 117, think about it. Think logically. Can 5 be a factor of 117? No. 13 we have to check. But can 13 and 5? Can you take another number than 13 and 5? You can't take, because then it will be 1 only, right? So one of these two numbers has to be factor of 117. Okay. So take with 13. I think I'll get how many times? 9. 9 is 27, 9 1 is 1, and then 2 11. I get what? 3 times of 3. So I get 3 square times 13. Okay, that's my prime factors of 117. What's the HCF, bacha? HCF is the common factor 13 with least power, so answer is 13. Now they are saying that 13 is written in the form of this 65m times minus 117. So write it here, 65m minus 117. They are saying this is the HCF of the numbers is given in this form. Okay. Bring this, divide everything by 13. I get what? I get 5m minus 9 equals to 1. And dividing everything by 13. So 65 by 13 will be 5, 9, and this is simply 1. Bring this 9 on that side. I get 5m equals to 9 plus 1. So I get m equals to simply 2. 9 plus 1 is 10, by 5 is 2. M is 2. Answer is 2, sir. 2. Moving on. Alright. Question number 3. If LCM of two numbers is 48, then which of the following number cannot be the HCF? Okay. Achha, one thing I forgot to mention. Not forgot, I wanted to do it over here only. HCF of A and B is always a factor of LCM. Okay. LCM of what? Again A and B. Very important note. Very important note. Please have a look. So I'll give you examples also. So I'll give you examples. Like look at here. What is HCF? 8. Is it factor of 720? 8 90s are 720. Take the previous question. Over here I've taken HCF. Okay. What was my HCF, bacha? HCF was 1. Was 1 factor of 63? Yes, it is. Okay. Take the previous example. Over here. What was HCF? HCF was 4. HCF was 4. What's the LCM? 24. Is 4 a factor of 24? Yes. So if you check all these examples, our statement is true. What is the statement? HCF of any two number A, B is always a factor of the LCM. Okay. So this HCF you see here, these numbers, this has to be HCF, right? For this to be HCF, it has to be a factor of 48. They're saying not the HCF, cannot be the HCF. It means the number which is not a factor of 48 will be, which cannot be an HCF. The number which is not a factor of LCM cannot be a HCF. So check here, 15 is my answer. Is 15 a factor of 48? 15 is not a factor of 48, hence what? Hence it cannot be the HCF of what? Of any given numbers, okay? Of any given two numbers. Understood? Simple enough, okay? HCF is always a factor of LCM for any given conditions. Moving on. If two positive integers a and b are written as, now variable is involved. Please write here, a is written as x power 3 and y power 2, and b is written as, b is xy cube, xy cube, xy cube. X and y are prime numbers. Why prime numbers? Because it has to be prime factors, no? The numbers has to be in prime factors. Then HCF and LCM of AB is what? Let's see. What we do for LCM, bacha? First thing, LCM we consider all the factors. So x and y and highest power. Highest power of x is what? Check here, 3. Y is what? 3. This is my LCM. What about HCF, bacha? HCF will be what? Common factors only. X and y is common factor. So x and y with least power. What is the least power of x? Only 1. Least power of y? 2. What's my answer? xy square. So my answers are x cube, y cube and xy square for LCM and HCF respectively. Simple enough. This is what? My A, this is number B. Moving on. Same approach you can apply for all this thing. That's why I said that approach is method 2 is applicable for both variables and numbers as well. Chaliye. Moving on. Question number 5. If 7 is the least prime factor of P and 11 is the least prime factor of Q, the least prime factor of P plus Q is what? Okay. 7 is, please check. 7 is least prime factor of a number P, and what I get for 11 is another least prime factor of Q, Please understand this. For any even number, bacha, for any even number, what will happen? I take the number, let's leave it at 84, 846, 94846. Any number I am writing. What's the smallest prime number which is a factor of this? Always the least prime factor will be what? Prime factor will be what, bacha? Will be what? It's going to be 2, right? In all the cases. For any even number, the number, it will be divided by 2. What is a 2? 2 is the smallest prime number anyway. So for any number that you have, the least prime factor will be what? 2, which is even. For any even number, least prime factor is always 2. This is simple, this is clear, okay. So if I have any other case, if I have, let's say 3, 5, 7, it means it will be odd number. True. For all the even numbers, we have the least prime factor as 2. It means for other number, which is odd number, what is the least prime factor other than 2? Which is going to be 2, 3, which can be 3, 5, 7, anything. So please check here. If 7 is least prime factor of P, it means what? Sir, P is odd. It means what? P is odd, sir. P is odd, sir. Because if it was 2, then I can say it is even. But 7 is the least prime factor. It means P is odd. And what about Q? 11 is the prime factor. No, 11 is the least prime factor. Again, Q is odd, sir. Then what happens, bacha? P plus Q. Sum of two odd number is what? Even, sir. Please check. Any two odd number, add them. What is the result? Even number. So P plus Q is even. Then what is the least prime factor of P plus Q? How much is that going to be? Tell me. 2 only, no. How come, sir? This is even, no. Since we got P and Q as odd, the sum will be even. So least prime factor of P and Q will be 2. So even only. What is the answer? least prime factor of P plus Q is 2, sir. Good question. All right. Moving on. An army contingent, okay, of 104 members is to march behind an army band of 96 members in a parade. Okay, the two groups are to march in the same number of columns. So we have to think of a column. We have to think of the column. Okay, so which should be what, bacha? Which should be forming the equal, means let's say the members contingent this contingent members will walk behind what, the army band. So army band will be in the front, then members will be behind those people. Okay, so we have to think of how many numbers. We have to think of the rows, same number of columns. Okay, okay, what is the maximum number of such columns? Now think about it. Think about it. I write the two numbers. We can understand and address the question from the statement wise. I can give you a smarter trick to solve this question. Very, very simple. Take here 104 and 96. Now just think, just tell me. Just look for the possibility. Okay, can this number that you're looking for, what number? Number of columns. Number of columns. Let's take this to be x. Can this number x ever be equal to 96 or 104? Or can this be more than this? Ever? Can the number of columns be more than the people there? No, sir. So this will always be less than 104 or 96. In that case, what we are looking to find, sir? What? HCF. Correct, na? So we have to figure out the number of maximum number of such columns where all these people can fit equally. Okay. So if I do that, what am I gonna do, bacha? Tell me. I have to find first thing is to find HCF. First thing is what? Find the prime factors. For 104, what are you gonna do? 104 is going to be, first thing is, please do the prime factorization here. It's going to be 252. 52, how much is this? Please check. 226. Again 2, how much is that? Please check. It's going to be 13. So 2 into 2 into 2 into 13. So 2 cube into 13. Am I right? Please cross check. 52, 26 and 13. Yes, correct. Correct. What about 96? What about 96? Please have a look. 96. 2 with 48. 2 again with what? How much is this going to be? 24. Next what? 2 again I can take with what? 12. Okay. I can take again 2 with 6. 2 with 3. So how much is this going to be? 2 power 1, 2, 3, 4, 5. So okay, correct. 32 times of 6 is what? 32 times of 3 is 96 only. No problem there. Okay. Now let's have a look. 1 second. I'll show you something. Okay. So what is it? 2 power 5 and 3. We are looking for HCF. What we do for HCF? Please tell me. Common factors with least power. What is the common factor? Only 2 is there. What is the least power? 3 is the least power. So my HCF is what, bacha? My HCF is going to be 8. What is this? My maximum number of columns. Maximum number of columns so that they can march in. Maximum number of what? Of column is what? 8. Is what? 8, bacha. My answer is 8. Okay, and I hope you understood this. All right, this is it. Okay, this is it, bacha. So this completes our first session for your series, which is 99% in 99 days for your boards examination. So to download the PDF, do not forget to fill the form and enroll to get all the updates, all the videos and the notes for the sessions. Okay, in your mail only. Okay, if you are new to this channel, subscribe to the channel. Okay, I hope this has been helpful. We're going to continue with the entire session. We'll complete this entire approach very simply. Any comments you have, any suggestions you have, comment, give me the suggestions in the comment below. Okay, let me know anything that you want me to do, or you have any query, let me know all of that. Okay, I'm here to help you out in whatever way I can do academically. Okay, any other queries that you have, put in the comment section and let me try to help you doing that. Okay, subscribe the channel. Put always try to check again and again. Okay, and solve the questions again and again for different topics. Okay, so solve the questions. Whatever I've solved in the session today, download the PDF from after joining the link. from the link and download the PDF, solve these questions again, because I have solved it once. You have to solve it from your side also to be sure that you understand the concept very well. I'll see you in the next session. For now, please take care, be positive, keep working hard. I'll see you in the next session. Take care. Bye-bye.